I'm John Woods. I'm the CTO at the Algorand Foundation. Algorand is a killer Layer 1 blockchain, and I'm here today to tell you a little bit about some of the things we've been up to and where we're thinking of going with Algorand. It's a short presentation. I think it's quite punchy, so thanks for coming out and listening to me. So Algorand launched on mainnet in 2019. It's 4 years ago. And in that time, we have gone from a very initial implementation of Algorand to one that is quite sophisticated. So over those years, we've processed 1.1 billion transactions on the mainnet, and we've had over 31 million blocks. But critically, this all occurred with zero downtime. Uptime in systems is hard. Uptime in distributed systems is even harder. And so Algorand has managed to process over 1 billion transactions all without a single second of downtime. And this gives Algorand a key characteristic which is absolutely essential: reliability. So thinking of Algorand in terms of enterprise-grade technologies, I think you have to remember that programmable blockchains, at their essence, are really operating systems. They're decentralized operating systems, but they're still platforms for executing applications. And when you're building a traditional application in an enterprise context, you want to make sure that you're executing on a reliable platform. And that's, of course, why the internet is run by Linux. And it's why, when mission-critical applications are being executed, they're run on embedded or very reliable operating systems. Algorand gives you that reliability in a decentralized context. So Algorand is a Turing-complete Layer 1, which means you can program and express any level of sophistication within a smart contract. It has 10,000 TPS in mainnet, and it can support that. And very importantly, where a lot of chains will talk about transactions per second, which is not really a metric that I think is that important, once it's over a certain threshold, of course, Algorand's TPS values don't dip when you're interacting with a contract the way other chains do. So you'll see other chains, and they'll say 50,000 TPS. But then when you jump into it and you see, what is the TPS value when you're executing an AMM, when you're executing a swap, when you're interacting with a sophisticated contract? And of course, what happens there is that that contract is running inside the virtual machine on the node, on the network, and the virtual machine cannot process that as quickly as it can process a standard payment transaction. But Algorand has been engineered from the ground up, learning from the mistakes that were made with the EVM architecture. And at the core of Algorand, its smart contract execution platform, is the AVM. I like to think of the AVM like the Apple silicon of the blockchain space. It's efficient and fast. It focuses on speed and precision. And so within the AVM, you can actually play with native 512-bit integers, as an example, straight out of the box. And so one other aspect that I think is critically important is finality. And a lot of people talk about finality in the blockchain space. There is one unique property of Algorand that sets it apart from its rivals. Algorand has true instant finality. And what I mean by that is that with Algorand, once a transaction is in a block, it is completely final. On many other chains, including great projects such as Ethereum and Cardano, you will have sometimes short rollbacks, block height battles, where a chain that's been deployed to the network and has been accepted as valid is rolled back and replaced with a longer chain, or indeed a different chain. And so this happens all the time. These block height battles occur. These chain rollbacks occur all the time. And what usually happens in an enterprise context, where you have a mission-critical application, is that you have to watch for these rollbacks and replay your transactions. Now, that brings a ton of middleware into your application. Within Algorand, because of the VRF primitive, the consensus algorithm, consensus is reached by 100% of the network on every block. And so this means as soon as a transaction is in a block, which occurs every 3.3 seconds, your transaction is completely final. So this reduced the costs of execution, it reduced the cost of maintenance of applications on the platform, and it gives a killer user experience, where folks don't have to worry whether a transaction is really done. They don't have to wait for confirmations. So what have we been up to over the last few months? One of the things that I think is increasingly on the agenda is quantum security. And so what I mean by this is all of the blockchains that we're using at the moment use elliptic curve primitives. They use elliptic curve cryptography. And so this is a mathematical technique that uses elliptic curves defined over finite fields for the security of the digital signatures. It's very well understood, and it's been around since the 70s. The thing about elliptic curves is that they can be the discrete logarithm problem, which is the core of their mathematical hardness, can be solved by a quantum computer trivially. And so we're starting to see serious entities look at the quantum scene and start making changes. So recently, Google Chrome was updated in version 1.16 to include Kyber, which is a key encapsulation technique that's post-quantum. And so Google is looking at their browser technology, and they're making code changes to make sure that it's ready for the advent of a quantum machine. At Algorand, we're known for our academia, we're known for our prowess within the cryptography space. Of course, our founder, Silvio Micali, is one of the best-known cryptographers on Earth. So we're taking the step to include quantum-resistant cryptography in the layer 1. And so we've done this the right way. We've brought Falcon, which is a NIST-approved post-quantum digital signature scheme based on lattices, to Algorand. So the entire history of the Algorand blockchain is secured by a lattice-based PQ signature scheme. And so this means that even if a quantum machine was to be attacking the chain at this moment, it wouldn't be able to disrupt the history of the chain. Another wonderful technology that we've developed over the last year that I'm particularly proud of is ALGO. One of the things that I think was a drawback of building on Algorand was that it's not as simple as EVM. You can't just fire up your JavaScript devs and get them to roll out applications. On Algorand, you needed to deal with tooling that wasn't as mature as Ethereum's. And so we recognized this, and over the last year, we've released ALGO, which is a complete end-to-end solution for realizing your applications on Algorand. And this takes you on the entire journey from build to test and to deploy. And so we're on version 1.4 now, and we have done a ton of things. Algorand helps you build unit tests. It quickly helps you compile, test with CI/CD incorporated, and indeed deploy on either testnet or mainnet within a few seconds. We've also, in version 1.4, added the ability for ALGO to help you actually build the web UI front end for your dApps. Because, of course, a dApp is not just a smart contract on the chain. Your users also need to interact with it. So ALGO even helps you there. It helps you build the front end as well as the back end. So I'm particularly proud of what we've done with ALGO, but we're not stopping there. So let's talk about where we're thinking of going. So, of course, on the protocol side, everyone's focused on TPS and numbers. So we're going to be implementing dynamic round times and increasing throughput. But I think, even as it stands, Algorand's throughput is really high. Maybe more importantly to me is decentralization. So Algorand at the moment is a hub and spoke model. That means that the blocks are produced in a permissionless way by participation nodes or consensus nodes, but that data is propagated across the internet with a hub of relays, a bit like a ring road. And so we're moving away from this relay-style network to a gossip or peer-to-peer style network using libpeer-to-peer. And so what will happen is we will be increasing the number of consensus nodes that are on the network. We'll be deprecating the relays, and all of the data transmission or data propagation will occur right through a peer-to-peer gossip-based network, not requiring any relays. And we're going to make sure that we do that in a way that doesn't affect our finality, of course, at the heart of the consensus, nor the current block time, which is about 3.3 seconds. Also, another major tectonic shift in Algorand's vision is that we're going to start incentivizing consensus. A lot of folks are maybe unaware, I know I was when I first started looking at Algorand, that block production on Algorand is not rewarded the way it is on Ethereum, Cardano, Bitcoin, etc. And so to go hand in hand with our peer-to-peer gossip-based network, we're going to be incentivizing consensus. And so this has a number of impacts. Number one, it increases the number of channels for data propagation from peer-to-peer. And most critically, number two, it will see a massive surge in the amount of algo that's being staked when individuals who have maybe smaller positions are together forming a large mass that's securing the network. So I'm particularly looking forward to moving forward with real decentralization. So finally, I'd just like to talk a little bit about AlgoKit 2.0. And so this is the kind of magnum opus of developer user experience on Algorand. As I mentioned a little bit earlier, platforms like Algorand are effectively operating systems. Okay? And if you think of the developer experience on Android with Android Studio, or you look at VS Code, it's great, right? People enjoy using it. It's the same on the Mac with Xcode. Xcode is a great user experience. And so AlgoKit 2.0 is going to address one of the suboptimal parts of building on Algorand right now. So build, test, and deploy is now complete. It's good. We have great CI/CD support. We've got great test support. There's only one part of the developer experience that I'm not happy with, and that's the language. Currently, when you're building on Algorand, you've got to use Teal. And Teal is like an assembly-like language. It's not very fun to develop in. It's certainly not fun to debug with. And it's hard to learn. And I think maybe most importantly for end users, when you want to build an Algorand, you want to take advantage of some of the cool things that we have, like the 3.3-second block time, the instant finality, and all that cool stuff. You got to go and you got to hire a specialist Teal developer. It's expensive, and it's expensive to maintain. It's expensive to develop, rather, and expensive to maintain. So with AlgoKit 2.0, we're bringing pure Python development to Algorand. And what this is going to allow you to do is to build applications for Algorand's Layer 1 in real Python, without concession. So this is not going to be a weird syntactic variant on Python, actual Python. And you'll even be able to do line-by-line debugging. And so this brings a huge change in terms of the inclusivity for Algorand. So everyone from kids in university who are learning prototyping in Python for the first time, all the way to, of course, the hot topic at the moment, the ML AI guys who all build in frameworks around Python. Everyone will have the knowledge to deploy contracts on Algorand. And so this is a significant change in how easy it's going to be to build and how inclusive Algorand is. As well as that, as I mentioned earlier on, this changes the cost profile. So it's no longer going to cost a lot of money to hire developers to build your apps. And of course, it makes maintenance trivial. So that's a look at some of the things we've been up to. Thanks so much for listening to me. I do really appreciate it. Thanks a lot.